Hi, my name is Chris, and we are excited to share our talk with you, Procedural Block-Based USD Workflows in Conduit. About 3 years ago, Blue Sky Studios began the journey to rebuild our pipeline to help us tell better stories. We were excited to take 25 years' experience of ray tracing in production and combine it with many exciting new commercial and open source projects that have uh, entered our industry. The goal of our new pipeline was to embrace a philosophy of progressive refinement, meaning assets and shots were renderable at any time. Artists could work in parallel as much as possible, and any artist from any department could contribute meaningfully at any point. A key piece of this endeavor was USD. USD gave every department and every artist a common scene description for collaboration as well as rendering. The rich composition features of USD were also attractive for encouraging new workflows and finding better ways to work together and amplify our efforts. Adopting USD led many departments to embrace Solaris and Houdini, um, outside of the usual suspects of effects or crowds. We also began to use RenderMan for the first time via a custom USD to RenderMan translator, because our new pipeline project began so long ago. There was no Hydra render delegate for RenderMan or really any renderer. And so until Hydra was able to do everything that we needed it to do, we used our own USD to RenderMan bridge. Another key piece of the new pipeline was a dependency management and version control system called Conduit. This was built in-house at Blue Sky and was an important new development for our studio. To better understand our block-based workflows and how they worked, and it's useful to have a good understanding of some concepts from Conduit. So in Conduit, the atomic blocks that artists work with are products. And a product is a repository of data and files, not unlike a Git repository for code versioning. These products are identified by a PRI, and that PRI is a unique ID, and it stands for Pipeline Resource Identifier. We use PRIs and refer to them in the same way one might refer to directory structures in a more traditional file-based pipeline. So products could be tailored to specific uses, and two of these specialized products that we use were entities and elements. An entity is a product that represents a shot, an asset, or a scene or sequence. Element products are the contributions to these entities, such as an asset's shader or a shot entity's lighting. Artists contributed to entities through an element. Artists never directly edit the entity. That part is controlled by the product itself to ensure correctness and reduce mistakes and unexpected behaviors. As USD is a key cornerstone of the pipeline, every entity and element product has a root USD layer. In addition to these USD layers within an element, artists generally contributed to a core variant. Core variant was our convention for two USD variant sets, model and resolution, which were found on nearly every asset by default. This provided some structure and consistency for our artists who were getting up to speed on working in a USD pipeline. So hopefully this short overview helped set the stage for what we will talk about next. If you're interested in learning more about Conduit and our new pipeline, check out our other talk called A Pipeline Retrospective on USD and Conduit. Now let's talk more about the design workflow we set up.
This is Wayne, and I'll be talking about the design and implementation of the workflow. First, I'd like to explain the motivations behind our design. One of the first things we did was establishing the USD and Solaris knowledge required by artists. As we transitioned from a non-USD to USD pipeline, most artists do not have USD experience. While we did provide a lot of USD trainings for artists, it was still hard to expect everyone to fully understand and exercise every concept. And since Solaris mostly interfaces with lower-level USD operations, it would require significant upfront knowledge to correctly work in it. As such, we defined features that artists were expected to know versus those that were not expected. This in turn gave us a direction to decide what features to hide away from artists so as to minimize the USD prerequisite. While we want to account for the majority of standard workflows, we also want to ensure flexibility to extend workflows. The first iteration of our tools, which followed more closely to the default behavior of Solaris, was bottom-up. If we simplify a typical workflow as 3 steps: first, set up the contribution; second, author the work; and 3, export a USD file. Then in a bottom-up workflow, artists would first set up the contribution, author the work above it, and then come back down for the final export. This, however, proved to be less intuitive since step 2 often depends on information in step 1 and making the order of operations as well as the quick dependency confusing to artists. Therefore, we wanted to change our workflow to be top-down, where artists start with the contribution setup and work their way down sequentially in the network. And this was intended to make it more intuitive and match the way artists work in other Houdini contexts. Another problem we faced was that artists would frequently see a different result in the exported USD file than what they saw in the Houdini working session. For this reason, we wanted to build up artists' confidence in their work by making sure that they're explicitly aware of their contribution and what they see is what they will get when exported. The problem of inconsistency requires a bit of explanation. In LOPS, changes always happen in the top-level active layer. However, in our old workflow, artists would use a node like asset import or shot import to import the whole entity USD file. And on the right here, we can see the layer stack, in this case with the shot USD file as well as some elements within it. We then mute the working layer so that the data from previous version is not carried over. For example, if we're working on the effects element, then we would mute the effects USD file. And artists are now ready to start authoring the work to the top level active layer. And when they're ready, they can export out the active layer to the same USD file. Finally, we inject the layer back in the exact location in the layer stack of the entity using tools like layer replace. However, the composition result for this workflow can actually be different than what you get if you're authoring the layer at the exact location in the layer stack. Reusability and scalability of the workflow were also something we would like to address based on early prototypes. To reuse workflows, artists were taking advantage of context options and exploring PDG to parallelize processes. To make sure that context options in PDG can be used correctly, we must ensure that our custom tools are fully procedural and compatible with expression. Having a top-down workflow helps make the workflow procedural, as we can more easily leverage upstream data like primitive paths or data passed via the Houdini layer info primitive. And here's just a guideline of how we made tools more procedural and some mistakes we made. In the process of generalizing and simplifying the workflow for artists, we identified 3 key steps in our workflow. The first step is identifying the current working root layer, which we call the scope. The working root layer is the USD layer that an artist would be working on and contribute to as part of a greater pipeline context such as a shot or asset entity layer. The second step is the configuration of the target primitives, as well as any preparation of stage for editing by the artist downstream. And finally, we can compose the artist's work back together with the larger scope using an appropriate USD composition arc and following liver piece. So how does this all connect to the block structure idea? We came to this solution of using block structure as it addresses our need to having a top-down workflow. So after dropping down the block, artists can work top-down from the start node to the end node. And the block also explicitly encapsulate artists' work so they are aware of exactly what they're contributing to the current scope that they're working on. And now if we look at the 3 steps, the block itself is the scope. And the start node configures the stage and primitives for artists to work on after. And finally, the end node is where the composition actually occurs. And these 3 steps just embody the core working of our block-based design. And these blocks can be nested or merged as shown in the diagram here. And another benefit of using the block, as we will see later on, is that you can now encapsulate any custom workflows inside either the start or end node to add additional features. Now let's take a look at how we actually implemented these ideas. Element block was one of the first blocks that we implemented and was essential to our Solaris workflow. It is used by all Houdini-based departments to author data to their corresponding elements. For example, a material artist would use the element block to contribute to a material element. An effects artist would use it to contribute to an effects element, etc. And the scope of the element block is the element USD file within an entity. We configure the start node to target the specific element based on a given PRI by the artist. And for the end node, we sublayer the element back into its corresponding entity. Additionally, element block is customized to recompose the entity explicitly, so the default output of the whole block would be the whole entity. And the end node also has a USD ROP node to export out all USD files within a block. Finally, we also allow artists to edit the existing element layer instead of creating a new one. The element block is used by all Houdini-based artists in Conduit regardless of asset, scene, or shot work. We generalize the tool for any entity and any element, such that all workflows essentially starts by using the element block. So as part of making artists' work more explicit, we leverage the block structure to explicitly rebuild the entity such that the composition of the artist's working layer is most accurate. Instead of previously using nodes like asset import or shot import, which would bring in the whole entity USD file, we now dynamically separate the layer stack of the entity into weaker elements and stronger elements with respect to the current working element. We put the weaker elements in the start node and the stronger elements in the end node, and sandwich the working layer in between. And if we look at the layer stack now, this corresponds to how the layer would be positioned after being exported, relative to stronger and weaker layers, and therefore presenting it this way to the artist ensures that the final exported USD file will match what they see in their Houdini working session. For our asset works, we introduced two blocks to deal with our core variant structure. As shown earlier, for our asset structure, each core variant will have a payload file and a layer file. The payload file contains data that would be payloaded, while the layer file is an additional level of abstraction to encapsulate the payload. The core payload block here is targeted specifically to the payload USD file. It configures the scene to have a payload primitive, which by convention is where we usually put the data that are meant to be payloaded. And using the same block nodes, we also have an additional setting that will allow artists to use a payload block as a normal payload block without actually scoping to a specific core variant. On the other hand, the core layer block targets the layer's USD file specifically. Similar to the core payload block, we configure the start node to be modifying a specific core variant, except this time the data is defined outside the payload prim and scoped under the asset root. And the end node uses the reference arc to bring the content in, and as well as creating the actual variant sets if they do not exist on the asset. And here's an example of using all the blocks we've talked about so far together. In this case, we are creating 8 different core variants of an apple. We have high and low resolution variants. Within each variant, we create 4 additional variants for the different level of completeness, from the full apple to just the core. And since we want the definition of the geometry to be part of the payload, we scope the edits for each core variant within the core payload block and nothing inside the core layer block. And all of the blocks go within one element block, which in this case is for a model element. And in addition to our core workflows, here's an example of how a department also adopted the concept for more department-specific workflows. For effects, we built the effects component block, which allowed artists to separate out different components within the effects element to their individual payload files. We configured the primitives to follow standards established by the effects department, such as the primitive name, purpose, and kind. And in this case, the composition for the end node is using the payload arc. And here's an example of using the component block. There are 3 blocks here, or 3 components: snow dust, snow powder, snow chunks. And when artists work within each block, they work specifically on the component. At the end, they merge all 3 components going into the element end for the overall snow effect as part of just one effects element. And on the bottom left, we can see how the primitive paths for each component has the same structure as defined and configured by the start node. And now I will pass it to Kenji to talk about some additional workflows we've introduced on top of the block workflows.
Thanks, Wayne. This is Kenji, and I'll be discussing the additional workflows that built upon this core block toolset. We built tools that allowed artists to leverage the inherits arc in our USD asset structure to prototype or broadcast their contributions to a set, shot, or scene, which allowed them to target proxy primitives without breaking instancing. This setup allowed an artist to use the identical block node setup to edit and author asset materials, for example, in either isolation or in context of a shot. An artist could use the asset doctor to either render their work in context, or if desired, they could author that USD data as shot overrides by using a shot element block to export the class overrides into the shot element. Building on the asset doctor workflow, the asset broadcast tool allowed an artist to work from a shot context and choose how they want to push their edits into the asset. They could identify an instance proxy asset to do work on, such as one of these lamppost references, and within the asset broadcast block nodes, they can make ad hoc changes to the asset, such as fracturing it, adding geometry, or modifying materials. They could opt to either push those edits into the source asset or use those edits as shot overrides, which makes use of an internal block nodes and internal asset doctor. They could also opt to target only specific instances of an asset in a scene by scoping the changes within a unique variant set and switching the variant set selection on the reference prints, which the node could do automatically on toggle. These toolsets were deployed and used on a short series in a feature production and proved intuitive for artists to use. So what worked? Particularly with many new to USD and Houdini, the combination of the block workflows and Solaris enabled both artists and TDs to understand USD, asset structure, and conduit concepts more visually and intuitively. Artists were able to step through a graph and visually see in the viewport in the scene graph tree how their contributions would compose and fit into an existing asset or shot. The block workflows ensured that advanced USD knowledge was not a prerequisite to contribute into the pipeline. Artists and TDs with more USD experience were able to extend the typical workflows for advanced discipline use cases, such as for effects and for procedural environments. The explicitness of the element block, combined with tools such as Asset Doctor, allowed artists to do their work and see how an asset or shot would render and compose with downstream contributions, such as from lighting. Artists could work in the context of a shot and choose to author their edits in either the shot or into the original asset's context. In addition, the element block allowed both artists and TDs to easily debug where opinions were coming from. For example, when debugging a shot, a user could easily check whether the opinions were coming from an upstream department, their local edits, or downstream departments by stepping through and displaying the element start node and the element end node. Because the tools were not reliant on callback scripts and could be initialized at will, TDs were able to make use of Houdini layer info, context options, and PDG attributes to create procedural and reusable authoring setups, which could be generic across Houdini-based disciplines. The modularity of the toolsets enabled our team to create tab tools and template browsers to automate node graph setups. Users could pick the element they wanted to work on, the variant they wanted to target, and begin their work. Houdini layer info global parameters helped us to track contextual data such as the working element and the working variant set, and allowed us to automate subsequent nodes to auto-initialize based on upstream authoring choices. And what could work better? The tools were designed to account for 80% of the typical use cases, and there was still some work to be done to make the last 20% of use cases more efficient. Performance was an ongoing developing challenge, particularly as we saw more large sets go through our pipeline. A drawback to our implementation was the overhead that each end node imposed. The nodes composed the artist's work, but did so in a new stage because of composition arcs within some of the end nodes. Because of this, along with the recomposition cost of the new stage, Hydra would clear itself out and resync the primitives from the new stage. These composition arcs and end nodes contributed to negligible cook times when working component prop assets, but these factors contributed to poor interactivity in heavy set assets, particularly heavy sets with variants. While the block workflows worked well for typical asset and shot modification workflows, the block nodes could be cumbersome when editing assets and shots at scale. For example, while users could reuse parts of their node graph when modifying 10 like-as shots in a sequence, they would need to have an element block per shot, which could result in a sprawling network. These challenges could be addressed through future work. The heaviest cooks in our block nodes came from the end nodes, which were authoring arcs such as variant sets and reference arcs into the asset structure using vanilla Solaris composition lobs. Since those arcs are only authored onto our root prim in our asset structure, it would be possible to rework our implementation to mask and isolate only the select prims that are needed and author those arcs manually in SDF. This would reduce the need for lobs to recompose the full prim hierarchy on those end nodes. We could also create invisible composition arcs and export only via ROP context options, rather than live if the arc does not affect the prim hierarchy or the in-session behavior of the working asset or the shot. In addition, block-based population mask is another possibility to improve interactivity in heavy scenes. A shot artist could start with the whole stage, and then, similar to the effects component block workflow, we could allow an artist to break down a shot or a scene to target different prims or subtrees in nested blocks, which could leverage unloaded payloads and population load masks to reduce the complexity of the stage and the viewport in any given part of the graph. While block nodes were procedural and reusable, advanced setups that use context options or PDG required some technical setup. Artists were also able to work on multiple shots or assets at a time and merge them together, but that could result in large graphs for some setups. To more easily enable multi-shot and multi-asset modifications, a future version of this toolset could potentially accept a list of products or a list of variants to do like-as modifications to, and the blocks themselves could handle the context options or the topnet setup under the hood. If we were to further integrate PDG into block nodes, we could allow artists to do like-as shot modifications, such as adding a light rig into 5 like-as shots within a single element block that targets a list of shots. Our work would not be possible without the fantastic artists, TDs, and engineers at Blue Sky Studios. We would also like to thank Side Effects, particularly Mark Tucker and his team, for providing valuable development insights throughout this whole process. We hope to see you at the Q&A soon. Thanks so much.